Good morning, viewer. Bienvenidos. Here is the breaking news for our view. Optical illusions. Optical illusions play on the brain's glasses, tricking it into perceiving images differently than how they really are. And now, in mice, scientists have harnessed an optical illusion to reveal hidden insights into how the brain processes visual information. The research focused on the neon color spreading illusion, which incorporates patterns of thin lines on a solid background. Parts of these lines are a different color, such as lime green. In the example above, and the brain perceives these lines as part of a solid shape with a distinct border. A circle. In this case, the closed shape also appears brighter than the lines surrounding it. It's well established that this illusion causes the human brain to falsely fill in and perceive a non existent outline and brightness. But there has been ongoing debate about what's going on in the brain when it happens. Now, for the first time, scientists have demonstrated that the illusion works on mice, and this allowed them to peer into the rodents' brains to see what's going on. Specifically, they zoomed in on part of the brain called the visual cortex. When light hits our eyes, electrical signals are sent via nerves to the visual cortex. This region processes that visual data and sends it on to other areas of the brain, allowing us to perceive the world around us. The visual cortex is made of 6 layers of neurons that are progressively numbered V1, V2, V3, and so on. Each layer is responsible for processing different features of images that hit the eyes, with V1 neurons handling the first and most basic layer of data, while the other layers belong to the higher visual areas. These neurons are responsible for more complex visual processing than V1 neurons. Until now, scientists have debated the extent to which V1 neurons respond to illusory brightness, such as the brightness people perceive when looking at the neon color spreading illusion. In a series of lab experiments in mice, researchers have now shown that these neurons play a fundamental role in this process and that their activity is also tempered by feedback from V2 neurons. So, there is volley back and forth between these different layers of the visual cortex. This knowledge may bolster our understanding of consciousness. The researchers said in a paper published last April, journal Communication. The observed relationship between V1 and V2 in processing the illusion implies that consciousness is a top-down process as opposed to a but author Mastaka Watanabe, an associate professor in the Department of Systems Innovation at the University of Tokyo, told Life Science in an email. Top-down processing refers to the way our brains interpret our surroundings by taking prior experiences into account rather than solely relying on visual stimuli alone. By contrast, pure bottom up processing would take the different features of an image and snap them together like puzzle pieces, making a coherent picture without input from a person's memory. Other studies have implied that consciousness is a top-down process, but the mouse study provides direct evidence for it. Watanabe sure the answer is not black and white, though, as some argue that consciousness likely arises from a mixture of both. BN's exclusive report.